Now coming to the SVM formulation, we have stated that we want to minimize half W transpose into W with constraint that target value into W transpose into Xi plus B is always greater than or equal to 1. So as we have seen earlier, this is f of xy and this is g of xy, and this we can write it as 1 minus ti into w transpose into xi plus b is less than or equal to 0. So Lagrangian formulation, we want to find w and b for these conditions. This is our objective. So w, b and lambda is equal to the f of x, that is the of w transpose into w, plus, because we have many points, it is not a simple term, it is sigma summation I is equal to 1 to n lambda I into the condition 1 minus ti w transpose into xi plus b. Now let us find the derivatives. Do L by do W first. So this is W square derivative with respect to W is 2W and 2 gets cancelled there. So W minus sigma I is equal to 1 to n. Lambda I derivative is 0 with respect to W and the term here is W. So and lambda I, Ti and Xi. Of course this term will also be 0. Then dou lambda by dou L by dou B is, all this term will be 0, this term will be 0, this term will be 0. Here it will be minus term, minus and minus lambda I Ti. Then dou, if this is equal to 0, W will get as sigma I is equal to 1 to n lambda I, Ti and Xi, and this is equal to 0. Now substituting in this equation to find W and B and lambda for optimal. So for optimal W, for optimal B and lambda, of course, is half W transpose into W plus sigma I is equal to 1 to n lambda I minus sigma I is equal to 1 to n lambda I Ti W transpose minus I is equal to 1 to n B lambda I Ti. Because lambda I Ti is equal to 0, we can ignore this term and let us substitute W transpose and W here. What is W value? W value is sigma. So I will substitute the values here. These are optimal values. Half W transpose is lambda sigma lambda, let us take one as j, lambda j tj xj into, this is I, lambda I ti xi, this is x transpose, this is xi, plus this will be lambda I, and this will be minus, already I is there, I is equal to 1 to n lambda I ti transpose can be expressed as j is equal to 1 to n lambda j tj x j transpose. If you see, this term and this term are very similar. This is half and this is half minus 1, it will be minus half. So minus half sigma, sigma, one is I, another is j, lambda I, lambda j, ti, tj, xi, xj transpose plus sigma lambda I. So if this condition is fulfilled, we can get the W value from this equation, and from this we can calculate W value and we'll calculate B value. This is known as dual form, and where we started, that is known as primal form. This is primal form, and what we got is dual form. So we can calculate W from this equation and B also from the equation that Ti into W transpose into Xi plus B is greater than or equal to 1. If it is support vector, it is equal to 1. From this we can calculate B, and if you have any, after finding W and B, suppose you are given with a point X, then we'll calculate W transpose into Xi plus B. If this value is greater than plus 1, we'll categorize it as positive category, and if this value is minus 1, we'll categorize it as a negative category. This is the mathematical solution for the SVM.